In the last module, we focused on how a firm determines its production function in the short run. In other words, when one variable remains fixed over a certain period of time, a firm is operating in its short run, and it produces a particular quantity of a good or service. However, we said in the long run, all costs become variable, and therefore a firm's decision in the long run in terms of production function and quantity produced will be different than in the short run. And it will include economies of scale for some firms as they produce more. So we're going to take a look at how that is determined in this module. So in this module, I'm going to first explain why a firm's costs may differ between the short run and the long run, and also describe how a firm can enjoy economies of scale. Here's a question that from the 2010 AP Microeconomics exam, question 19. I wouldn't expect you to be able to answer it yet, but it gives you an idea of what type of question might be asked on the exam. And so if you would like to, you can pause the video right now and read through this question and see what the answer is. It's important to remind you that the key difference between the short run and the long run is one of variable inputs, and when one remains fixed and when one doesn't. So in the long run, all inputs, land, labor, and capital, meaning even plant capacity, can be changed. The plant size can be adjusted upward for an expansion of the plant or downward for a contraction of the plant in the long run. So for example, in the long run, given enough time, McDonald's can open a new franchise. A local restaurant can build an expanded dining room. General Motors can close a factory in Indiana. A professional baseball team can build a new, larger stadium. A college can build a new dorm to house a larger student population. A regional pizza monopoly can close an unprofitable franchise in a nearby town. Because these actions can only take place in the long run, these things can't happen in the short run because they take time to occur. These are costs that are only incurred in the long run, and this is what differentiates long-run costs from short-run costs. So we're going to be looking at both short-run and long-run production costs. We've already looked at short-run costs, but remember, in the long run, all resources are variable. There are no fixed resources. Plant capacity and size is changeable, and so today we're going to examine long-run costs. So here's a more expanded definition of the long run and its purpose. In the long run, as we've said, all resources are variable, and plant capacity and size can change. Why does this matter? Well, because the long run is used for planning purposes for a business. Because firms make plans for what they can produce in the short run when they can't change the size of the plant, but they also make decisions for what they can do over the long run when they can change it. So firms use to identify which plant size results in the lowest per unit cost. So assume a firm is producing 100 bikes with a fixed number of resources. Fixed number of workers, fixed number of machines, whatever it might be. If this firm decides to double the number of resources, what will happen to the number of bikes it can produce? Well, there are only three possible outcomes. The number of bikes will double, that we would call constant returns to scale. The number of bikes could more than double, we would call that increasing returns to scale. Or the number of bikes will less than double, and we would call that decreasing returns to scale. So what happens to the average total costs of a product when a firm increases its plant capacity in the long run? Well, here are some examples of various plant sizes. I make looms out of my garage with one saw. I rent a building, buy 5 saws and hire 3 workers. I rent a factory, buy 20 saws and hire 40 workers. I build my own plant and use robots to build looms. I create plants in every major city in the United States. All of these are examples of different sizes of plant capacity that could be changed in the long run. So the long-run average total cost curve is made up of all of the different combinations of short-run average total cost curves of various plant sizes. So let's go back to our example of Eli and Max and their lemonade stand. Eli and Max are considering investment of new capital and expansion of the lemonade stand. They have been squeezing lemons by hand, but they could buy a new mechanical squeezer. They have also been confined to a small shack that serves as the factory, but they could rent a larger, more permanent space on a busy street. Investment and expansion is expensive, so fixed costs will rise, but this would give workers the ability to be more productive, so variable costs will fall. So let's say that fixed cost doubles from $50 to $100, but the variable cost is cut in half at all levels of output. We can see in this table that at low levels of output, the average total cost curve number 2 is greater than the average total cost curve for the first short-run curve. This is because the more fixed cost spending on expensive equipment and expansion is outweighing the savings in variable cost. Now, if the lemonade stand can't produce more than 32 cups of lemonade, expansion doesn't make sense. However, as the higher fixed cost is spread over more units, the ATC2 becomes less than the ATC1. If the lemonade stand can sell more than 32 cups, expansion will provide per unit cost savings. We can graph both ATC1 and ATC2 to better see what is happening in the table. Both ATC1, let me skip over this one for a second. Both ATC1 and ATC2 represent short-run average cost curves. They represent two sizes of the firm, one small and one large. But at each of those sizes, the fixed inputs are fixed. Of course, the firm could choose many different sizes, not just small and large, over time. The implication is that for such a firm, many possible short-run average total cost curves will exist, each corresponding to a different choice of fixed cost, and so giving rise to what is called a firm's family of short-run average total cost curves. So think about this. At any given time, a firm will find itself on one of its short-run cost curves, the one corresponding to its current level of fixed cost. A change in output will cause it to move along that curve. If the firm expects that change in output level to be long-standing, then it is likely that the firm's current level of fixed cost is no longer optimal. Given sufficient time, it will want to adjust its fixed cost to a new level that minimizes average total cost for its new output level. If the firm finds the lowest possible average total cost that can be achieved for each output level when fixed inputs are free to change, we can now draw out the long-run average total cost curve. Specifically, the long-run average total cost curve, called LRATC, is the relationship between output and average total cost when fixed cost has been chosen to minimize average total cost for each level of output. Now, economists often label the horizontal axis as plant size to signify that along the long-run average total cost curve, it's not really daily output that is fluctuating in the short run. It is long-run production capacity that is changing as the firm is expanding or contracting the fixed inputs. So if we go back here and look at another example with Selena's gourmet salsas, again, you can look at the chart below and you can see one short-run cost curve when she has low fixed cost, which is on the left-hand side of the panel, and another short-run cost curve when she has high fixed cost. And so this would create two different short-run average total cost curves for her. You can see at low output levels, if you look at the graph with the two average total cost curves graphed, at low output levels, low fixed cost yields lower average total cost. And then as output levels get higher, high fixed cost yields lower average total cost. So there is a trade-off between higher fixed cost and lower variable cost for any given output level, and vice versa. But as output goes up, average total cost is lower with the higher amount of fixed cost. And so, to redefine this, the long-run average total cost curve shows the relationship between output and average total cost when fixed cost has been chosen to minimize average total cost for each level of output. Now, a firm may choose to increase their fixed costs in order to increase output. Overusing space can cause supply issues, so firms expand which increases their total fixed cost but may actually decrease their average total cost. So this leads us to something called economies of scale that a firm may experience. Now, why do economies of scale occur? Firms that produce more can better use mass production techniques, and they can develop specialization in production. Here are some examples. A car company that makes 50 cars will have a very high average cost per car. But a car company that can produce 100,000 cars will have a low average cost per car. Because using mass production techniques like robots will cause total costs to be higher, but the average cost for each car would be significantly lower. And that would result in an average total cost curve that would look something like this. And you can see we have our familiar U-shaped average total cost curve with marginal cost declining in the beginning because of increasing returns to scale. And then as a firm experiences decreasing returns to scale, marginal cost will rise. And the firm will choose to produce the quantity where average total cost is at its lowest, and that is where the marginal cost curve will intersect the short-run average total cost curve. In this case, that would be producing just over one car. Now, we said what happens in the long run is that firms have different short-run average total cost curves. And depending on the fixed cost that it chooses over the short run, that's going to change its short-run total cost curve, thus making a family of short-run average total cost curves, each one U-shaped and each one having a different marginal cost curve. But in each situation, a firm is going to choose to produce, in the short run, the quantity of a good that will minimize average total cost for that short-run period. And it will be where that marginal cost curve intersects the average total cost curve at its minimum. So you end up with this family of short-run average total cost curves that a firm can choose from. And it's this family that, taken together, makes up the long-run average total cost curve. Because long-run average cost with economies of scale is falling because mass production techniques are used. And that's why the short-run average total cost curve 2 has lower average total cost than short-run average total cost curve 1. And a firm would end up producing more cars in the second average total cost curve than it would in the first one, and it would be doing so at a lower average total cost because of economies of scale. Here you can see, if we continue that logic, if a firm chose to increase its plant capacity even more, it would be spreading out its fixed costs over even more units. That would lead to a third average total cost curve, which is a short-run average total cost curve that would have lower average total cost than the previous two. And a firm would produce at the minimum of that average total cost curve, so it would be producing an even greater quantity of cars at a lower previous average total cost than before. Here we add a fourth one. Now, in this example, notice that the average total cost curve for the fourth short run period looks similar to the average total cost curve for the third one. This is because at a certain point, a firm may achieve what we call constant returns to scale rather than decreasing returns to scale. And when that happens, that means that the lower long-run average total cost is as low as it can possibly get. And a firm cannot get a long-run average total cost any lower than that. Then, if a firm decides to expand even more, it may end up achieving what we call diseconomies of scale. And here you can see that average total cost curve 5 has a higher average total cost at its minimum than average total cost curve 4. When this occurs over the long run, we call this diseconomies of scale. Long-run average costs increase as the firm gets too big and too difficult to manage. And its costs actually go up as it produces more. Here is a video produced by Mr. Clifford on economies of scale to help you understand the concept of economies of scale even more. This is a very important concept for you to understand. It does get tested frequently on the AP exam, so you want to make sure that you understand the concept of economies of scale and the difference between this family of short-run average total cost curves that a firm can choose from and how that family of short-run average total cost curves makes up the firm's long-run average total cost curve with decreasing returns to scale and then possibly constant returns to scale and then oftentimes increasing returns or what we call diseconomies of scale. So go to the ACDC Econ website and view this video. So when we talk about returns to scale, what do we mean? Well, when we have economies of scale, the long-run average total cost is falling as the firm expands. In this range, the firm is benefiting from expansion due to increasing returns to scale. Now, remember, the phrase economies of scale is usually used to describe the downward sloping long-run average total cost curve. The phrase returns to scale usually refers to the production function. These are essentially synonymous, and they can be described as also meaning that output is increasing at a faster rate than production costs. You might imagine the lemonade stand that increases total cost by 50%, but this allows the firm to increase output by 100%. Now again, why would a firm enjoy economies of scale? Well, there are several reasons to explain this. One is because of specialization. The firm expands and finds ways to give labor and capital opportunities to perform tasks that are best suited to their talents. For example, a firm could purchase a machine that is both a copier and a fax machine. When the firm expands output, this becomes inefficient because Eli needs to make copies, but this requires Max to have to wait 30 minutes to send a fax to the lemon supplier requesting more lemons. This is inefficient. So the firm buys a new fax machine that allows both Max and the machine to be more specialized. A second reason why firms enjoy economies of scale is because of high initial setup costs. A large piece of capital is very expensive when it is initially purchased. But if the firm can produce many, many units, the per unit costs fall as that high cost gets spread out over more units. And then economies of scale exist. A third reason why we have economies of scale is because we buy inputs, land, labor, or capital, in bulk. Larger firms need lots of raw materials, and when they are bought in large quantities, the per unit costs are lower, like when you shop at Costco. Think of buying 24 single cans of Coke from a vending machine versus buying a case of 24 cans at the grocery store at Costco. And so there are all of these short-run average cost curves that a firm has. And as I said, each one of these short-run cost curves taken together represents the family of short-run cost curves that a firm can choose from. And it can choose which short-run cost curve it wants to be on. And then it's always going to produce the quantity of a good that is at the minimum of that firm's short-run cost curve. But if you draw a curve that is tangent to the minimum of each of the short-run average total cost curves, you will then derive and draw the firm's long-run average total cost curve. And notice that is shown here with the red curve. The short-run average total cost curves that make up the family are shown in blue. And when we draw that red line that is tangent to the minimum of each one of the short-run average total cost curves that make up the family, that becomes the firm's long-run average cost curve. And it will choose where to operate on that curve. And if it operates at the minimum, it will be operating with constant returns to scale. Because before that period, long-run average total cost is declining, and the firm is achieving what we call economies of scale, or increasing returns to scale. At the minimum of the long-run average total cost curve, a firm is experiencing constant returns to scale as its average total cost is not declining any further, and then if it produces a quantity beyond that, it will actually be achieving diseconomies of scale, or what we call decreasing returns to scale, as its long-run average total cost curve will actually increase. So, what are diseconomies of scale? Well, as you can see here, when long-run average total costs are declining, that is the portion of the long-run average total cost curve that we refer to when we call it economies of scale. There are decreasing average total costs during this portion of the scale, or this portion of the curve rather, and so we call those economies of scale. Once we reach the minimum point on the long-run average total cost curve, then average total costs begin to rise, and we call those diseconomies of scale. Now, why does that happen? Well, long-run average total cost is rising as the firm expands even further. In this range of the long-run average total cost curve, the firm is no longer benefiting from expansion due to decreasing returns to scale like it was earlier on. This simply means that output is increasing at a slower rate than production costs. You might imagine the lemonade stand that increases total cost by 100%, but this allows the firm to increase output by only 50%. Now, why would a firm suffer diseconomies of scale? Well, because of problems with coordination and communication. Huge firms, multinational corporations, large companies have offices and subsidiaries spread all over the world. And it takes time, effort, and money for them to coordinate production, marketing, and sales activities within large firms. So at some point, the firm becomes so large that per unit costs actually begin to rise, and a firm experiences diseconomies of scale and increasing long-run average total cost. And so you can see this is what a firm's long-run average total cost curve would look like. It would be decreasing in the beginning in the portion where they are experiencing economies of scale. It would reach a minimum point, and then if it increases its plant size and output beyond that minimum point, long-run average total cost will begin to increase, and a firm will experience diseconomies of scale. This is an activity that we will do in class to practice this concept. This is another activity that we'll do in class to practice. Again, here is a cost curve that shows this once again. So once again here we see the firm's long-run average total cost curve, and you can see visually here the portion of the curve where there are economies of scale, constant returns to scale, and diseconomies of scale over the long run. And you need to understand what each of those terms means in terms of returns to scale. Here's a simplified version of the long-run average total cost curve. You can see the law of diminishing marginal returns does not apply in the long run because there are no fixed resources. So we only have diminishing marginal returns in the short run because one resource is fixed, and eventually that leads to diminishing marginal returns. But in the long run, because we can change all of our inputs, we can choose a portion where we do not have diminishing marginal returns, and that's because no resources are fixed. In class, we're going to be working on doing some graphing production. So here again, you see a review of the 3 stages of returns. Stage 1 is increasing marginal returns, where marginal product is rising. Total product is increasing at an increasing rate. And why is this? Because specialization occurs during the portion of the marginal product curve where we have increasing marginal returns. In stage 2, the firm experiences decreasing marginal returns. In this portion of the curve, you can see marginal product is falling. Total product is still increasing, but it's increasing at a decreasing rate. Why is that? Because in the short run, resources are fixed. Each worker adds less and less to total production than the previous worker. Then in stage 3, we experience negative marginal returns. Marginal product here actually becomes negative and dips below the axis, and total product is actually decreasing. Why? Workers are getting in each other's way and becoming less productive. So now, take some time. You won't have a partner to do this with, I don't think, but you should take some time and calculate in this graph marginal product and average product, and then look at what the graphs for total product, marginal product, and average product look like. And remember, quantity of workers always goes on the x-axis. So if you completed your first calculation, this is what the marginal product curve numbers should look like. And then here is what the average product numbers should look like. So you can use this to check your work and see if you calculated these columns correctly. Now, you should pause the video and see if you can identify the 3 stages of returns that we just talked about. Remember, there's a stage where we have increasing marginal returns, decreasing marginal returns, and then negative marginal returns. See if you can identify those 3 stages in this chart. And here is the answer to that. You can see when we hire the first 3 workers, we are experiencing increasing marginal returns. Workers 4 through 7, we experience decreasing marginal returns. And when we hire the 8th worker, we experience negative marginal returns. Here are some more examples of the law of diminishing marginal returns. Example 1 would be the learning curve when you're studying for an exam. What are your fixed resources? The amount of class time, the textbook, things like that. What are your variable resources? Study time at home. You can change that. Well, the first hour of studying, you get very large returns. You learn a lot of information and you're learning a whole bunch of stuff that can help you on the exam. If you spend another hour studying, you may learn a little bit more that will help you on the test, but probably not a lot more. If you study for a third hour, you may learn just a little bit more, but you'll probably add very little to your total amount of knowledge. And in the fourth hour, you may actually experience negative returns because by then you're so tired and getting confused that you're not studying well. A second example would be a farmer having fixed resources of 8 acres planted of corn. If he doesn't clear weeds, he will get 30 bushels. If he clears weeds, once he will get 50 bushels. Twice, 57. 3 times, he'll get 60. Additional returns diminish each time. Here's an activity we'll do in class. And so this concept is important to understand, sunk costs, and it's a very common mistake that people make. A sunk cost is a cost that has already been incurred and is non-recoverable. And so when making a decision, you should never consider a sunk cost as a cost of the decision because you can't change it. No matter what you decide, the sunk cost has already been incurred, you can't get it back, and therefore it shouldn't be a part of a decision on future actions. Sunk costs should always be ignored in making decisions about future actions. Because they've already been incurred and are non-recoverable, they have no effect on future costs and benefits. There's a saying, there's no use crying over spilled milk, because if it's spilled, there's nothing you can do about it. So you have to go on. Now, here's an example. Suppose you've purchased a concert ticket for $100 and you accidentally dropped the ticket in a storm drain, losing it forever. Should you buy another ticket or sit at home and sulk? Economists would say that the loss of the first ticket is a moot point. It doesn't matter. You can't get your $100 back. It's gone. Whether or not you buy another ticket depends on whether you can afford another $100. The first $100 is a sunk cost. It's been incurred in the past and it can't be recovered. College tuition is another good example. If a student is paid $10,000 in tuition, should she attend as many classes as possible so that those dollars are not wasted? Well, those dollars are sunk. You could go to class on a daily basis if you believe the benefits from attendance outweigh the costs, and those costs do not include one nickel of the $10,000. Here's another example. There's a significant difference in total costs that arise from making different choices about fixed costs. Washington, D.C. has fewer snowplows than Chicago, and therefore has fewer snow plows, or because it has fewer snowfalls. Washington, D.C. and Chicago are like two different businesses who have different expectations about output, meaning snow removal, and therefore they make different decisions about the level of fixed cost and how many snow plows they will have. This is an excellent summary of the concepts and measures of cost that were presented in this and previous modules. You should pause the video, copy this chart into your notes, and make sure that you understand each of these costs and how they change in both the short run and the long run for a firm. And here's a summary of this particular module. So you can pause the video here, look at the summary, make sure you understand these concepts, and this concludes our work with Module 56.